All right, hi everyone. My name is Aaron, and today for the advanced track, we're going to be going over Netcode, which is short for network code. And so Netcode is essentially the type of programming that lets you um, uh, design the communication or facilitate the communication between different devices on a network and different network applications or multiplayer applications. And so I just want to preface this by saying that I'm by no means an expert in this field. I just recently started learning about it last year, and this isn't going to be so much of a tutorial about how to make the perfect multiplayer game, but it's more going to be sort of a discussion on some of the important things that I've picked up, and hopefully um, by the end of this, you'll have a good foundation to start learning netcode on your own. The hope is that Studio will be able to kind of grow a bigger a bigger space for multiplayer games in the future. So with that being said, the first thing that you might want to have open is the GitHub repo, just so that you have access to all the links and stuff that we're going to be going over for today. So just a quick rundown of what we're going to be going over. The first thing is the client server model, which you've probably heard of before, but it's essentially just sort of one of the most popular ways of structuring a multiplayer game and connecting different users together. Um, it's also the one that Unity chooses to use for its own network code stuff. Next, we're going to be looking into what it actually looks like to code or to use the netcode in Unity. So some more some more specific examples, what the API looks like, stuff like that. And then finally, we're going to take a look at uh, a really good example of what good multiplayer network code looks like with Unity's Boss Room sample project, which is essentially a project they built in order to show off a lot of the features of their netcode package. So what does netcode look like, especially in regards, or what does it look like when you build a Unity network game or um, uh, a networked application that's built with something similar to Unity. So you can see that we have sort of some examples over here. You got Overcooked, which of course is a collaborative team game where you can play with your friends and you try to make food as you try to make the right orders as fast as possible for customers waiting in line. And so requires a lot of coordination, strategy, that kind of stuff. Then you got something like Totally Reliable on the right, which is more of like a fun sandbox sort of game where you can kind of play around and mess around with your friends. And so you can see that these are the sorts of games that you'd probably be building when we say netcode with Unity. These fun little games are, admittedly, Unity isn't typically built for these kind of like the large scale AAA title multiplayer games like Fortnite or something like that. But still, it just goes to show that you can build pretty complicated games with really interesting mechanics just with Unity and coding using netcode with Unity. And so aside from being able to do all this cool stuff, getting to have some really interesting interactions with other players and incorporate team play, strategy, all that stuff that comes with multiplayer games in general, it's also important to note that netcode is also a really powerful tool for many practical applications, such as sort of like collaborative environments where it's may not always be the easiest to meet with others in person, especially now um, when we're trying to social distance so much. So this is things like, if you can imagine, maybe you're in a team of architects or something, and you're trying to collaboratively design some sort of model or some kind of structure. And it requires kind of everyone to be sort of in the same room so they can kind of all look at it from different perspectives. Well, you can use netcode in order to design maybe a VR application where you can all kind of be in the same virtual world and look at the same thing at the same time and collaboratively build something that you guys are all looking at the same time, almost as if you were all at one location in a given point in time. And probably another big part of this, part of the reason why netcode is maybe pretty important now is that probably, as you know, many of the most popular games today are multiplayer games, games you can play with your friends. Uh, and these are things like, Minecraft, League. You got some other games like Sea of Thieves. Sorry, I'm just listing off all of my favorite games, but yeah, you can get the idea. Is that a lot of the most popular games, the games that we have most fun with, many of these are multiplayer applications, and so um, uh, programmers with skills in Netcode um, uh, are in very high demand right now, and so it's worth taking a look at and seeing if you're interested in doing some of this. So let's start off with some basic ideas, some kind of foundational concepts before we go into um, uh, the actual Unity network code. So as I mentioned before, the client server model is essentially is essentially a type of structuring for networked applications, a structure for kind of connecting together the different users on a network. There are different models like peer-to-peer and stuff like that, but this is sort of the client server model is sort of the most popular and the one that Unity chooses to use for their network code. And so the way it works is you have one server, so one computer that serves as the sort of the authority on what the game state is. So whatever is on that computer, whatever is on the server's computer, that is what the game truly is at any given point in time. And you have a bunch of clients which are sort of trying to approximate what's on the server at any given time. So you have the server that has the main true identity of the game, and then you have a bunch of different users connected to that server that are trying to approximate what's on that server. Obviously, so the idea is that um, you have sort of one central location for what the game should be. You don't have kind of competing versions across all the different people in the game. You have a single version that is the true and only the sort of the true identity of the game. And so um, obviously there's lag. You have some issues with not having updates in time, right? Because you have these clients and they're all connected to a server, and if a client wants to wants to try to uh, talk with another client, it has to go through the server first, and the server has to talk with that client. And so the idea is that clients don't always have exactly what's on the server, and so I want to stress that clients are sort of approximating, they're giving their best guess at what they think is on the server at any one given point in time. Because there's things like the things are distanced, things might be on different sides of parts of the world. You might have issues related to weather. The client can't get exactly what's on the server at a given point in time, and so it has to sort of give the user its best guess at what's there. And so usually each of these clients corresponds to one player in the game. Sometimes you might have kind of a variation of this where you have a client who's also the server, which is what you kind of see in things like Minecraft, which is where you have a host and a bunch of clients connecting to that host. A host is essentially a client that is also the server. Um, and this is what you would use typically in smaller games where you don't have a dedicated computer that can be the server for everyone else. Um, so I kind of mentioned this before, which is that there's this idea of delay between when when a player puts in their input and when they're actually going to get to kind of see the results of their input. And so this is what people mean when they talk about lag and ping. Um, it's essentially the idea that it takes time to get from a given client, right? When a client presses a button or something, that information gets sent to the server, and then the server has to go and update everyone else um, um, based on that input. Um, I think, sorry, something I forgot to mention beforehand was that the 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 strength of this client server model is that you have the server sort of serving as sort of the gatekeeper for the network. You if a client wants to um, change some data about the game, maybe you're you want to, I don't know, uh, increase the health of your character or something by by 100 hit points. Um, what you would do is you'd send that request to update your character's health to plus 100 hit points to the server, and the server can verify whether or not that's something that it wants to allow to happen, right? Since the server is the central authority on what the game state is, it is the one who also decides whether or not it should allow certain requests by the client. And you can see that this is um, very useful when it comes to defending against hackers who want to try to change the game state so that it's in their favor and disadvantageous for everyone else. So essentially, anytime the client wants to change something about the game, let's say maybe you're a hacker and you want to change the position of all the players so that they're all outside of the map or something all of a sudden, it has to go through the server first. So the server has to verify that request from the client is a good one before it goes and relays it to everyone else. So you can see there's no kind of direct path from any one client to another. It has to go through the server first before going to the other clients. So now let's go into what this actually looks like, what this kind of client server, these interactions sort of look like when we dive into actual code in Unity. So first off, you can so the idea with how this is going to work is that I'm going to go over a few core concepts um, in this netcode package, and then uh, and then you're going to go and go through with the Unity tutorial that they have on these topics. The idea is that uh, I'm trying to give you a good foundation to help you go through the tutorial a little bit easier. And so the first thing to mention, the first important part is the network object. So once again, so this is a package called uh, it's called uh, Netcode for game objects, and what it essentially is it just provides you all the functionality that you're going to need, all the special tools, also that special setup that you're going to need in order to do networked stuff with Unity. And so if we go back here. Um, One of those things that is included in the package is this new component called network object. So this is a component, right? This is something that you can drag onto any game object in your Unity scene. And the idea with this component is that it sort of serves as the identity of a given object on the network. So anything anything that's on the network, anything that interacts with the network has to have a network object component attached to it, because the network object sort of allows the network to communicate with whatever is on the game object that it's attached to. The network object has information about sort of like who's controlling this game object, what what the ID of this object is on the network, stuff like that. That's really important for being able to keep track of the different objects that are moving around on the network. The next important feature is the network variable, which is just like a regular variable in Unity, right? You can change it the same exact way. The only thing is that the thing is when you change a network variable on the server, it will automatically um, update this variable on other clients. So it's different from a variable in that if you just had a regular variable like a bool or something on the server system and you changed that bool from true to false, the clients by default, the clients wouldn't even know that you changed that variable on the server, um, because there's it, because there's no we haven't sort of set up the connection between the client and the server. Uh, so we could do it with regular variables, right? If we do change something on the server, we could send a special message to all the clients to update that given variable. But the idea with network variables is that it handles all of that for you, so you don't have to write the code to go and update all the variables on all of the systems. It's sort of to hide a lot of the complexity, keep you focused on what on other parts of the game, right? Where you don't have to worry about how the data gets updated on the other systems. And so once again, network variable, the idea with that is that it saves you time trying to synchronize data across the network. So as soon as you change the data on the server, it goes and updates that data for all of the other clients. And so this is kind of what it looks like in terms of code. You have sort of a one-to-one correspondence with a few data types that a few primitive data types, some other data types that you see in C Sharp. So in this one, you have a network list where you would normally see a list, right? This sort of is the same exact structure as a list, right? A list, and then you put in brackets what type of element you're going to have. In this case, an unsigned long. And so but this time it's just you have like network in front of list. So you kind of have like another like a parallel type, a network type for each one. So there's like a network bool, network int, stuff like that. Um, and so in this particular example, the way it would work is if you go and change, if you add like a new unsigned long to the network list on the server, then it would go and um, update all of the lists, all the lists on all of the clients, uh, and go and let them know that a new element had been added. And so if you remember, if this was just a plain old list and you added a new element to it on the server, nothing would happen to the client without you actually writing the explicit code to go and update it. So the network list by default goes and updates the list for everyone else. And so something I just kind of want to stress here is that I'm just going to do a quick little thing in Paint. Is that something that is maybe a little confusing is like how how do you know how does the client know like what variable was updated and stuff like that when it comes to network variables. So let's say that this is the on the left side we have the server and then on the right side we have the client. Basically, the server and the client both have a slot, sort of, they have a spot in memory for a certain piece of data, right? So let's just say this is like a network, I'm just going to abbreviate this, a network int, right? And so we have a network int over here too. And this is the same variable. So if this was called like num or something like that, this would also be the same num on the client side. So this is sort of this variable exists on both the server and the client at the same time. And so let's say we had this was 8. Let's just say this variable was 8, right? And then let's say uh, we go and change this. We go and update this to I don't know. We update this to oops. We update this to 5 now. So the way the network variables work, right? So um, what's going to happen is because we change this value on the server, right? We change it from 8 to 5. It's then going to send a message to the client to then go and update their variable to 5, their corresponding variable to 5. Um, and so if you had so now something important to note is that if you had some other network variable on the client, right? Let's say this one's a network bool or something like that, and this was true here. And so you have the network bool over here, and this was true. And let's say we go and update this one to false. Well, because we're on the client side, there's no the message isn't going to be sent to the server to update here to false, right? That's not going to happen because that would sort of violate our system of having the server be in control of all of the data that's going, all of the data of the game, right? The server is the true copy, the central authority on what the game is, what the game state is, and so that would kind of go against our this idea if we were to allow the client to be able to change data here and have it automatically update what the server has for the main identity, because the client isn't the one that should be responsible for the data, but the server is. Okay, so let me just go back to the slides here. Okay. So now that I went over some of these topics, now you get to kind of get to try to use them in Unity's network tutorial. And so this is sort of the first, I'm sorry, let me see if I can, okay, yeah. So this is sort of the, as you can see, the Hello World, the kind of the first project that you can do with basic networking stuff, just to get familiar with all the different things you're going to be using. And so just go through this tutorial. You're going to see some of the features that I talked about in the past few minutes or so. you're gonna see, I believe, yeah, RPC calls down here. Yeah, RPC calls, you're gonna see network variables, and hopefully by going through this, you'll, and especially with sort of this foundation, you'll be able to get to see how all of these things work out together. And you'll see some things like the network manager and stuff that we'll get into a little bit later. But the idea with this is just to uh, get some hands-on experience with um, how these things work in the actual Unity environment. So since this is a recording, I'll just go and say that if you want, you can pause the video here. And once you get back, we'll go and start with uh, some more complicated features when it comes to netcode. So, okay, so now we're gonna move on to um, so on that tutorial, you kind of learned what the different features are that come with Netcode, the Unity Netcode package, and sort of how you can fit them into your Unity project. So now we're going to kind of look into something a little more detailed. We're going to look into how you actually build the structure of a multiplayer game. And so um, I kind of showed this a little bit before in that little paint example that I had. But it's the idea that it's important to kind of note that the client and the server have the same exact code at any given time. So it's like pretty much the exact same project file that you're giving to the client and to the server. So this is just with Unity that we're talking about here. The way it works in Unity is that both the client and the server devices are given this exact same code at runtime. And so it is only after you kind of get some special inputs that you provide to the program that that program sort of becomes a client or a server. But the exact same code is given to the client and the server. And so to kind of illustrate this, um, I'll go back to that later, is essentially at the start, you have all of your code, right? So you have just ignore the server shared client, but you have sort of all of your code here. This represents your entire project code, right? Um, this is the exact same thing that you're giving to both the client and the server. And it's only at runtime that you go and sort of selectively remove parts of that program that don't correspond to um, what you're doing as a client or a server. And so the idea is that you have some parts of your code that are specifically meant for the server, some parts that are meant specifically for the client. And you sort of give all that code to both the client and the server, or the devices that will become the client and the server. And upon becoming the client or the server, they selectively choose which parts of the code they want to activate or deactivate. And in that way, they sort of become different. So they're kind of the same, and then they become client and server, and they kind of split and become different sort of programs, although they still have the exact same code with them that they're running at the same time. It's just that certain parts aren't active at any given point in time. So I mentioned that certain parts of the code are activated and deactivated based on whether you're a client or a server. So obviously, like the server code you can see here is deactivated when you're on the client, and when you're the server, you don't want the client code. Um, but there's that one other piece of code, the shared code that I kind of skipped over, which plays an important role that you can see doesn't get switched off even if you're based on whether you're a client or a server. And that's because the shared code is essentially um, the way that the client and the server communicate, right? So if you imagine if you completely, so if we didn't have the shared code, right, and we just sort of if you imagine the shared code wasn't here, we'd have a server, we'd have just client code on the client and just server code on the server. And so there wouldn't really be a correspondence between any data here. So let me just go back to the paint example. Okay, so basically you have your server code, right? You have your server code here, let's just say, and maybe you have your client. Sorry, I should use similar colors. You have your client. Okay, just imagine this is, yeah, I didn't want to use yellow because it might be a bit hard to see. But the idea is that you have your server code, right? You have your server, you have your server code here, and you have your client code here. We saw in that past example that if you wanted to change data, you kind of had to have a corresponding, you had to have that same data on both the client and the server, right? So maybe the client over here has um, a data member called num a or something like that, and num b. Sorry for my bad handwriting. And then for the server side, we have I don't know, bool a or something like that, bool b. And you can kind of see the problem here is that there's no, if you completely shut off the, sorry, let me make this more clear. So this is the server side, right? This is the server, and then this is the client over here. And basically, if you remember, we shut off the server code on the client and we shut off the client code on the server. And so you can see that there's essentially no corresponding value for num a right on the server because we turned off this code. It would have been over here, but we turned off the code. And so if this was like a network variable or something like that, there would be no connection here. Like where, oh, sorry, like where would this correspond to over here? There's no space because we turned it off on the server. So you kind of need, and same thing with the server, right? If this was like a network bool or something like we talked about before, and we changed this value, well, there's no kind of corresponding net bool on the client that we can change. Here it's like, because we turned it off on the client, right? So we kind of need some sort of intermediate stage between them, uh, like here, right? We need some kind of intermediate shared code, which does have some corresponding variable. So let's say we have like, I don't know, val, oh God, val a here, val a here, right? Now we have some way, let's say for the server to change some value on the client, right? If we change val a here, we can go and change val a on the client. And then maybe this triggers something that ends up changing num a or something like that. And that's how we do it. So maybe a change on the server causes something to change value a, then that can then directly change a value on the client because there's a corresponding kind of shared segment here, and that can maybe affect the data that's on the client only side. And so you can see that this sort of shared section right here is needed in order to have sort of a parallel between the server and the client. And so now probably the question is, why do we even have this shared segment? Like, why don't why do we even need to separate out the server and the client code in the first place? It just seems like a hassle to try to make this other shared segment to communicate. Like, why couldn't we just have um, something like, we just have one big block of code or something on the client and the server, right? So imagine we don't have this stuff on the top. We just have kind of one big monolithic chunk here that goes and talks with another monolithic chunk on the client. And the reason we don't have that, right, um, is because, well, so probably the main thing is we want to give flexibility um, to be able to for the network that we're using for the game that we're using to kind of switch between a host model and a dedicated server model. So in some cases, because if you think about the host, right, the host is both a client and a server. So it actually differs from what we see in this example here, where if you were a host, you'd actually want the server code on and the client code on, right? Because a host is both a client and a server. So by separating it out into different chunks, server, client, shared, we're able to kind of selectively choose which parts of the code we want to turn on and off at any given point in time. If all of a sudden we decide we want to make it a dedicated server model, well, then that's easy. All we need to do is just decide to turn off the client code whenever we run the server. But if we want to switch back to a host model, then we just have to note that we don't turn off the client code whenever something becomes a host. We just kind of leave it with the server and the client code still there. And so it gives us a lot of flexibility to kind of choose which parts of the code we want to activate at one given point in time. If we just had like a big monolithic chunk, well, we'd only be able to turn off that big monolithic chunk on or off, and that doesn't uh, I mean, that wouldn't really do anything for us because it would just turn off the entire game instead of just selective parts at any given point in time. And sort of another reason why we want to do this is because it helps kind of separate it out in our minds mentally what parts of the code, what parts of the multiplayer project are corresponding to client functions. So this is stuff like the UI system, stuff that the client sees on their end, versus the stuff that has to do with more like verifying, managing the data of the project, making sure that no invalid data is sent, sort of the more server side duties. Um, and so this is sort of kind of along the lines of the way you would think about like the component system, where you're trying to kind of separate things out into different responsibilities, different um, you're trying to get it so that each like bit of code sort of has their own responsibility, and that way you don't have other parts kind of getting tangled up with it and making it hard to extend and stuff like that. And so it's sort of the same idea here, where we're trying to separate out the server, we're trying to decouple the server code from the client code, so that it's a lot easier to test certain things. It's a lot easier to find where we're making certain changes based on like the nature of it, like if we're doing UI stuff or things related to the client, related to the server, and it helps us to disentangle server and client code. So let's see. Yep, this is sort of the idea with this once again is that um, this is just sort of like a visual of how this communication would work, as I was kind of showing before, which is you have a client. Let's say client A goes and makes a request. So it's going to go and contact the shared code. The shared code is then going to kind of serve as the interface with the server. So the shared code is sort of going to be the kind of the delegate of the client to go and talk with the server's delegate, which is like this shared code here. Once again, I'm not using delegate in programming terms, just as like someone who goes and talks for someone else. So you can see the shared code is sort of the one communicating between the client and the server. And then you can see once the server goes and processes data, it sends it back to the shared segment, which goes and then updates all the other clients. Okay, so now for the last part, we're going to be diving into what a good example of using all of these things that we talked about looks like. So this is Unity's sample project called Boss Room, which has a lot of uh, um, uh, Netcode best practices built into it. So it's a really great example to for getting started and learning how you're trying to supposed to architect a multiplayer game. Um, it's actually a pretty interesting game that you can go and play from the start. You just kind of have to follow the tutorial. But the idea with Boss Room is that it's sort of a model program that you can use to get ideas for how to start building your multiplayer game. In particular, Boss Room is sort of this 8-player game where you can work together with some of your friends to clear out a dungeon and fight a boss at the end, boss room. And so this one doesn't quite have a tutorial attached with it like the other ones, or like that Hello World tutorial that you just went over. Um, this one is more of you downloading the code and looking through how they do certain things. And this is kind of why I kind of wanted to do this tutorial in the first place, just to, because it can be a little intimidating to try to find like what you're supposed to do in Boss Room when they have all these features. They have, you can see they have some things on the side, uh, which kind of teach you a little bit about what's going on, but still there's a lot of code here, and so I think it would really help for someone to break down this kind of stuff. So um, yeah, let's dive into that. So when you open up the project, actually, I think a better way to do this is I'll just kind of run through some of the important features here that you'll see. So once again, the plan with this is that I'll run through some of the important features that you'll kind of see, and that way you have some context. You have a good foundation when you actually go in and try to look through the code yourself. And so, in the actual thing, we would have actually gone and tried to play this game, but you can go see for yourself. You can just follow the tutorial, and they'll walk you through how to kind of set up the server and play with your friends and stuff like that. Um, so the first key component to kind of look at here is the GameNet portal. And so this is something that comes with the project, right? It's the developers of Unity made this component, GameNet portal. Um, and the idea with this is that it sort of serves as the way for you to it's a little tricky to wrap your head around because it's kind of serves different purposes, but its kind of core feature is that it serves as sort of the shared code between the client and the server, like one of the shared components between the client and the server. So whenever the client has some information about like what scene it's on or something like that, it goes and sends it through the GameNet portal, which then sends it through to the server, and the server can register that information. But it's a little tricky to uh, understand by itself. So I'm just gonna kind of go right into the next one, and we'll kind of recap from there. So the network manager is another component that you saw in the Hello World example, but you didn't get really to do too much with it. And the network manager is essentially a component that this one's not um, specifically for the boss room game, but this is sort of one that comes with the netcode package, and this is sort of the main component that you need to actually set up the network. So it's the one that sort of starts up the actual server, and helps a client connect to a given server based on information that you put in about the connection, like your IP address, um, and or if you're using some other hosting service, sort of the room number and stuff like that. um, and so the network manager is sort of the central place that all of your network components go through in order to communicate with the network. And so I think it'll help if I draw another picture here about how these kind of components interact, especially in Boss Room. So in Boss Room, what you're going to see is you're going to see, so if you imagine this is your GameNet portal, I'm just going to abbreviate that right here. You have your GameNet portal, and you can think of Network Manager as being sort of this other thing over here. Okay. Uh, and so, as I was just saying before, this is sort of the shared component between this. This is not the shared component. This is like a kind of shared piece of code. So there are multiple of these, right? There are other shared pieces of code elsewhere, but this is sort of one of the shared chunks of code, one of the ones kind of facilitating this communication between the client and the server here in the game. So the GameNet portal sort of has you have your server part here and your client part here. And if you remember, this is just kind of the same thing that we saw back here, right? You have your server code, you have your shared code, and you have your client code. And so there's sort of like a server version and then the client version here that this GameNet portal serves to facilitate the communication between. So this part is going to go and connect to this, right? Okay. So what you'll kind of see in Boss Room is that when you start the game, you're gonna go and once you click through the stuff, right? You go through. Actually, it might help if I bring up Boss Room. But so what you'll see is that you're gonna go and essentially press a button here, right? So this is like a figurative button. You're going to go and activate something on the GameNet portal. And what that's going to do is it's going to go and fill in information to the network manager about your connection information, like your IP address or the IP that you're trying to connect to, or the room number, the port number, stuff like that. It's going to send it to the network manager. And the network manager is going to go and activate and then go and start up the server itself. As you can see, so this is Boss Room. This is what the project is going to look like. When you start up the game, you're going to be met with sort of this start screen here. Uh, And so you can see this is where you kind of input your information about the port number, IP address, stuff related to connection. Um, and when you hit confirm, you go and enter this new room. So you can see that you joined a room, and this is sort of um, what's happening in this process that I was talking about here, where you're in the room, right? You press start, right? You press the start button, you enter into your information, and the start is actually connected to the GameNet portal, which then goes and calls something on, passes on this information to the network manager, which then activates and goes and lets the device know whether or not it's a server or a client. So there are different routes here that are important to kind of look at. And so let me just clear this up because it's getting a little cluttered. Um, basically, so you know how I was talking about how you have like the client part and the server part deactivating based on whether the device is a client or the server. Well, that little activation thing that I was showing with the network manager, that's sort of like the signal that lets the client and the server stuff know whether or not to activate, right? Because or whether or not to deactivate. So the network manager goes and gets that information from the GameNet portal, right? So you have the GameNet portal over here. And it gets that information, the network manager will then know whether it's a client or their server. In the game, you can choose to be a host or you can choose to join a lobby, in which case you're a client. And once that information is passed to the network manager, it then realizes, oh, okay, I'm going to be a client or I'm going to be a server. And then it sends out that information. It's going to go broadcast that information and let the different components know what that what the identity of the system is. So in this case, if it's a server, then the server code is going to be like, okay, I'm just going to stay awake because I'm a server. But the client part is then going to deactivate because it realizes it's not a server anymore. In the case if it's a host, in that case, the client and the server would stay on because it's both the client and the server. But so the network manager essentially tells all the scripts. That's the one that lets all the scripts know whether to turn off or on based on the network manager essentially holds the identity of the system. And once that identity, whether it's a client or server, is established, it goes and lets the rest of the code know, and then it goes and starts up its thing. And so um, something that sort of you might have noticed is that, and probably one of the bigger features here, patterns is this client shared server pattern. This is just what I ended up calling it, which is that, and and once again, I'm not an expert in this, but this is just something that I noticed in Boss Room, and this is probably something that will show up in a lot of the other multiplayer games that you make, is this idea that of not only that we split up things between client shared and server, but we sort of, this is more speaking to what properties each of these parts has. So we know that there's a client, there's a shared, and there's a server part, but we haven't kind of established what sort of roles they play in each part. And so the way it tends to work in Boss Room, and what you'll see when you're looking through the code, is that each scene sort of more or less follows this pattern where there's a client part to the scene, there's a shared part to the scene, and there's a server part to the scene, right? Each one a different script. And so we're going to go sort of over what their different roles are in facilitating the process, facilitating this moving through the gameplay of that given scene. So if we take a look at the character select screen, right, that's the one that I went into after I pressed start and it made up the room. It put up these different sort of icons here. Um, so as I mentioned before, the server is in charge of all of the data in the game. It's in charge of identifying what the true state of the game is. And so what the server ends up doing is whenever it changes data on the screen, or whenever it changes the game state, it goes and sends an update through the shared scripts, and the shared scripts will then go and send an update to the clients, which will then update the UI. So something kind of important to note is that the UI sort of serves as the user's view into what the game state is at any given point in time. Whenever the game state is changed, the UI should change with it. And the UI can only change when it gets notified by the shared scripts. what might be a little confusing here is that the shared scripts hold the data. I know I talked about how the server is the one that's controlling the data. Um, in a sense, it still is, but in this architecture, the shared code contains the the data of the game, which comes in the form of networked variables, right? Networked lists, networked bools, and essentially this shared portion. This portion is shared because sort of, and this is something that gets a little more complicated, and you'll have to look into a bit more uh, on your own by diving into the code. But the idea is that this the data needs to be shared because the events that it sends out whenever it changes needs to be um, on this shared level. Basically, these variables, as I said before, that shared part needs a corresponding one-to-one thing between the client and the server, and so this shared data has to be on the shared script, has to be on the shared script um, in order for this communication to happen. And so that what the server does is essentially this: whenever the server feels that the shared data is ready to be changed, it goes and updates stuff in the shared portion of the script, and then it goes and then that sends a corresponding update to the shared portion on the client side, which then goes and updates the client. And sorry, I know there's a lot of detail to cover in this tutorial, and honestly, there's a lot of small things that are kind of difficult to explain in the short amount of time. But I'd say if you can take anything away from this last part, right, this last kind of confusing part, it's the idea that of this client shared server structure where the client scripts are always trying to sort of give the user a visual representation of what the current game state is, and the game state itself is stored in the shared portion, which is manipulated by the server portion. So the shared portion has all the data, the server controls that data, it changes that data, and the client part then updates the visuals, updates the UI in order to reflect that change in data to the user. So in the case of sort of like the character select screen, like when the game state changes, like a new character is chosen for a different player, then that shared data is changed, right? And the client goes and updates the UI so that that character is selected on the screen. Um, and I'd say probably my biggest piece of advice for looking through this and trying to figure out Boss Room is to um, start off with just going to sort of not diving straight into the client shared servers part, but kind of look at where everything starts. So in the game, right, when you first start the game, um, and you go ahead and you press the start button, well, from here you can kind of go and look at, sorry, let me just go here. In the main menu, right, you have your, let's see if we can find it. We want to find, yeah, the host button here, right? And from here, we see that it calls this function here. We see it calls main menu UI dot on host clicked, and so we can kind of trace it back here. Open up the main menu UI script. Let me bring it over here, and then you can kind of see where this starts. So then you might go and try to find main menu. Oh, or sorry, you might want to try to find what was it called? Start host. Or sorry, on host clicked. Right, you can see. So this function is going to be called, and then let me turn off this. So you can kind of see, so when you click the button, you know it calls this function, and then you can kind of go from here. Okay, what happens when I click the host button? Oh, it calls relay host, or it calls start host uh, based on what mode I select, and then you can kind of follow this trail all the way through and kind of see what's going on at every point in time. So yeah, so that's probably my biggest advice. Go and try to start from the start button, right? What happens when you click the start button, and then try to trace what happens, how it gets to the network manager. If you can kind of just remember my GameNet portal picture that I drew, keep that in mind. It goes through the GameNet portal, which then goes to the network manager, which then kind of activates and forms identity as the client or the server. And from there, you can kind of explore the different paths there are in Boss Room. Okay, so that will be the end of this tutorial. I know there's a lot of information and um, there are a lot of complex topics that I wish I could have gone into in a little bit more detail. But once again, if you have any questions about this stuff, or if you just want to talk about it, you can just let me know in a message on Discord or through email, whatever, and I'll be happy to talk more about this. I think it would even it'll probably be a lot more helpful if you're having trouble with going through this stuff if you just want to talk about it. So with that, thank you guys for um, attending this tutorial or this discussion, rather, I'd like to say. And once again, I just want to say that the main point of this isn't really to teach you how to make a full multiplayer game, right? I myself don't have that skill set yet, but I'm more of an enthusiast on this topic, and I really wanted to share what information that I've gathered over the course of the last year on this kind of stuff. And hopefully, Studio will be able to make some pretty interesting multiplayer games, network applications, a lot more in the future. Um, yeah. All right. I'll see you guys next time.